Hi, and welcome to another episode of SQL Tips. And today we're going to talk about ranking, how to get a ranking figure for a row in a record set, such as the first or second or third in a certain ordering criteria. Now, we've got numerous ways to do that, but we'll start off with a query here from good old AdventureWorks 2016 sample database. I'll give you the link where to get that database from Microsoft's website. But if we run this query here, just to quickly take you through it, it's sales order header, which is basically just a row that's a sale. It's got a value on it called total due. That joins to the person table based on the salesperson ID foreign key, and that joins to the sales territory table. And the ultimate result is, if we run that, the order ID, the date, the total due, the salesperson, and the territory. Now let's say that we're running a sales award competition and we want to find out which is the first, the second, and the third row of sale based on the total amount due. So let's just try this. There's several ways we can do it. There's actually three functions that'll get that for us, and we're going to use the first. So here we've got a function called RowNumber. Now I'll take you through the syntax. The function is RowNumber in brackets, no parameters going in, and then we've got sort of another function immediately after it. This is called the over clause, and the over clause has a bracket, and within it is an order by clause. Order by sales, total due from sales order header, and that's got your expression there. So before we go into the details of what all that means, let's just run it, and bear in mind that the set is ordered by total due descending. So the top ones are at the biggest ones are at the top. So if we run that, great, we have got a row number. It's a straight numeric expression, starts at 1, goes downwards, and it just goes 1, 2, 3, 4, 5, 6, 7, all the way down to the bottom, and that would be pretty effective at finding out which is the first, the second, the third, and so on and so forth. And you can actually see the total due. That's the highest one, that's the second highest, and so on and so forth. So let's go through this actual syntax of this whole thing up here. So we've got row number, over, and the order. An order by clause within the over clause. So basically that's saying, well, calculate the row number, and this is how you're going to calculate it. How are you going to order it in order to calculate the row number? And that's basically it, the order that you use to do it. So this can be completely independent of how you order the record set. For example, I could say, for example, I could just change this, and I will order it by sales territory, something completely different. And hey presto, a different order, but the row number still is maintained based on the ordering of total due descending, where the biggest one gets a 1, and so on and so forth. So the ordering is completely independent of the actual row set ordering. Very handy if you're doing reports, for example. You want a crystal report to print out in the order of sales territory ID, but you want this ranking figure on it completely independent of how the pages print out, that sort of thing. Now, I'm just going to put the order back up the way it was. Now, let's talk a little bit more about this over clause. So far we've seen you've got the row number, the over, and an order by in there. But let's go into the syntax of over. Now, I'm going to go to the Microsoft documentation website about the over clause, and let's just see what it's got to tell us. Determines the partitioning and ordering of a row set before the associated window function is applied. So I'll go through it again. Determines the partitioning and the ordering. We've seen the ordering effect because we passed in an order by clause and got a certain order of a row set before the associated window function is applied. The associated window function is actually this guy here, row number. Now, there actually are different types of ranking functions that will work with over, and we'll go through those in a second. So ordering we've seen, the partitioning we'll come to in a minute. We'll explain what that means. But let's come back here. Now, I'm going to show you a bit of a disadvantage with row number. If we come down here, notice that there's two sales order headers have the same total due. They're exactly the same. I actually manipulated the data to make that happen. You won't see that in your own copy of AdventureWorks. But Despite the fact that they're equal, they get a different ranking if we use row number. Row number just goes straight down, and that gets 4 and that gets a 5, despite the fact that they're equal. It just does it based on how the ordering tends to pan out. So, okay, that's not exactly representative of reality. So how do we fix that? Well, there is another type of ranking function that works almost as well, and that is rank. Now, rank is exactly the same thing as row number, but let's just have a quick look at how it works out. Okay, 1, 2, 3, 4, and 4. What's just happened? Well, the two sales orders that have the same total due, they are given an equal ranking, which kind of makes sense. The row immediately after it, instead of being a 5, which you might think, it actually jumps to 6. Because that's actually not, it doesn't make sense to make that a 5. There actually isn't a 5. That was sort of the 5, but it's not, because it's equal 4, you know what I mean? But that sort of matches it's almost the same as row number. So it's almost row number with some equals substituted in there. So great, might be perfectly fine for us. But, you know, if say we're giving out an award, and we want to give out an award to the 5th one, and we look down a list there and we go, well, hang on, there's no 5th. That kind of makes no sense. Well, there is yet another ranking function that accommodates that situation for us. And if I scroll down here, and that is dense rank. Now, dense rank works almost identically to rank, with one exception. And if I run it, and we go down here to the equals situations, yes, we've got 2 that are equal 4th, but the next one immediately after it is 5th. So there are no gaps. It basically fills in the gaps, which in some situations probably makes more sense. Now I'm going to go back to the documentation website about the over clause, and we're going to come back to one of the words that they mentioned. So the purpose of this over clause is it determines the partitioning and ordering of a row set before the associated window function is applied. The associated window function, we've seen 3 of them already, row number, rank, and dense rank. But let's go to the front bit here. Determines the partitioning and ordering of a row set. We've seen the ordering. So what's this partitioning thing? Well, let's just do some partitioning and see how it works. So over here we've got our good old friend, the rank function again. And I've basically inserted in here in the over clause within the brackets, before the order by, I've put in these words here, partition by, and one of the fields in our set, st.name, sales territory name. Now I've ordered by sales territory name first and then by total due. So if I just run it, it'll sort of make sense. So what we've done is we're ordering first by all the territories, Australia first, because Australia starts with an A. And then within that ordered set, we've got the total dues. And the rank has worked it out accordingly. Now the rank is within this set, obviously that's 1, and that's saying that that is the number 1 sales order based on total due within the set that is Territory Australia. And yeah, so if we scroll down to the next one, next territory, all the way down here, and it goes Australia, 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 and this is the first Canada one. What's just happened? Well, the ranking has reset itself and started at 1 again. So this is the first sales order based on total due for Canada. And if we scroll down again, and if we come to the next territory, which is Central, probably means Central America, again, it's reset itself from 692 to 1. So what partition by does is when it's working out this ranking, it first partitions it by a certain field, and then within that partition or that ordered grouping, orders it by whatever we want it to do. The order could be, within the set, could be completely independent of how we work out that rank. But again, if I order it by the same thing up here, then that kind of makes sense visually. So that's partitioning. Now, the beauty of partitioning is that we're not limited to one partition. We can have more than one. So what we've got here is the same query yet again, but I've messed around with the over clause a little bit, because when I come to the partition bit, I've got 2 partition fields listed. First, I'm partitioning by sales territory name, and then within each sales territory, I'm again partitioning by salesperson ID. And within that set of salesperson ID within territory, I'm ordering by total due. So now to make things clear, I've actually reflected all those three fields in my ordering down here. First, I'm ordering by sales territory, and then within territory, I'm ordering by salesperson, and then total due with the highest at the top. And let's just run it and see what happens. Okay, so our first ordered thing is Australia, because Australia starts with an A. That makes sense. And within the set that is Australia, we've got the salesperson. And if we scroll down here, we've got the next salesperson within Australia. And then we've got the next sales territory, and that's Stephen Zhang. And then within Canada, we've got Garrett Vargas. So how is that actually reflecting in our ranking? Well, let's have a look here. So Australia, that represents the number one sales order based on total due within Australia for Syed Abbas. So you can say to Syed, hey, Syed, when you were selling to Australia, that was your top selling order. Well done. And if we scroll down even further to Lynn Sophilius, I hope I've got that right, the ranking resets itself because we've changed salesperson. And you can say to Lynn, hey, Lynn, this was your top selling order when you were selling to Australia, and so on and so forth. And once we change partition again, whether it's salesperson or territory, again, it resets itself. There's Stephen's set, that's his number one order. And for Garrett, it's reset again, and that's his number one. So you get the idea. You can partition as many times as you like and separate them. And all you do is just simply type the fields and separate them by a comma. Now, coming back to our discussion about the over clause, it basically applies to a whole bunch of types of functions, aggregate functions as well, analytic functions, next value functions. We won't go into those, but if we talk about ranking functions, and these are the ranking functions that actually use overbuy. We've seen three of them, rank, dense rank, row number. N-tile is a sort of a thing that can get you, breaks up your record site into say quartiles or percentiles, that sort of thing. And I'd recommend you go check that out. But to give you an example, basically the over clause applies to any kind of ranking function, the ones we've seen, rank, dense rank. So if I take that same over clause there and I use dense rank this time, it all still works. So that's a pretty powerful and pretty flexible solution. Now, for a complete course in everything you could need to know about SQL and queries, check out my Skillshare course, and that will give you a complete rundown on SQL, and you can go in with absolutely no skills whatsoever and come out with enough industry-level skills to be able to take on any sort of query task you could possibly think of. And if you use the link in the comments, you will be able to get your first 2 months membership in Skillshare free. So go check that out, and I'll catch you in the next video.